So today we're going to learn about line segments. I'm Mr. Peacock. This is geometry. All right, so here we have a line segment, and today we're going to be measuring them. So the first way that we'll measure is just with a ruler. So in this case, to measure with a ruler, what you do is you take the end of the ruler and you put it at the end of the line segment, and you just go over. So if we look at this one in an example, it is exactly 23.5 inches. So this is a 23.5 inch line segment. But now let's talk about some other ways that we sometimes can measure line segments, like for instance, a number line. All right, to figure out how to find distance on a number line, we first need a number line so that we can find that. And then after we have that, we actually need a line segment. So to find this, what we need is a formula. And in this case, I'm going to say distance is equal to x2 minus x1. Now, for any line segment on a number line, x1 is the furthest left point, and x2 is the furthest right point. And so in this case, you would take the right point and subtract the left. Now, for our purposes, I do need a couple more things. First, I'm going to label the furthest left point A, the furthest right point B. I'm going to add a 0 there at our 0 spot. And from there, I find our other values. So our furthest left point, or our x1, is -7. Our furthest right point, or x2, is +3. So in this case, 3 minus -7 would equal 10. And the way we would end up writing this is the measure of line segment AB is equal to 10, or we would write AB without the line segment on top equals 10. If you have AB, all caps, without a line segment, that means the measure of line segment AB, or the distance from A to B, however you want to think of that. Let's look at another example here. So in this case, A is at -2, B is at 6, so we do 6 minus -2, which would be 8. And there we go. Now, let's talk about congruent segments. So here we have two congruent segments, AB and CD. Congruent segments are segments that have the same length, and we use tick marks to figure out how to show, in the figure, to show the congruent segments. The tick marks are just the little hash marks that you see right there. So the way that we would write this is one of three ways. First, line segment AB is congruent to CD. Notice the congruence symbol right there in the middle. It looks like an equal sign with a wave on top, or with maybe some toothpaste on top. Next, we have the measure of AB is equal to the measure of CD, because the measure of AB would be a number. It would be equal to the same number on CD. So while the segments are congruent, their measurements are equal, which means we could also write it as AB equals CD. And there we go. Let's go back to me. So that's what happens when we're using a number line, but sometimes we'll also use other things. So to start with, we're going to talk about what happens whenever we separate this into two parts, like this. There we go. And so one way that we can now find the measurement of these two smaller parts is by taking into account the segment addition postulate. To find out more about that, I cut to me. So let's talk about the segment addition postulate. But to get to there, we first have to talk about betweenness. So in order for you to say that a point B is between 2 points, A and C, all 3 points must lie on the same line, and AB plus BC equals AC. So on this top line, B is on line AC. Therefore, B is between A and C. On the bottom line, B is below line segment AC, and therefore is not between A and C. So now that we've talked about that, let's talk about the segment addition postulate. The segment addition postulate is just this. If B is between A and C, then AB plus BC is equal to AC. To see how that works, let's go back to me. Thanks, me. All right, so in this case, we already know that the whole thing had a length of, 23.5 inches. So if we look at just this top part, this is 18.5 inches, we can see right here. So the question becomes, if the whole thing is 23.5 and this is 18.5 inches, how long is this part? So what we would do is we would take 23.5 and subtract 18.5, and we would end up getting this length of 5 inches. So there we go. Now let's actually practice a few other types of segment addition problems. We can just use this again. I'll be back. All right, so let's try some segment addition postulate problems. So first thing I'm going to do is label my points A, B, and C. In our first problem, AB is 5, BC is 3. I want to find the whole length of AC. So AB plus BC is equal to AC. That is 5 plus 3. So AC is 8. All right, let's try another one. In this case, I know that the whole distance of AC is 13, and then BC is going to be 4. So once again, AB plus BC is going to equal AC, but in this case, AC is 13 and BC is 4. So to get AB by itself, I would subtract 4 from both sides. 13 minus 4 gets us that AB equals 9. All right, now let's try this one right here. So in this case, I know AB is 2x plus 5, BC is x plus 3, and AC is 5x minus 2. It's time for some algebra, but before that we have to remember AB plus BC equals AC. Let's just plug them in. 2x plus 5, x plus 3, and then equals 5x minus 2. So let's do some math. First thing I do, combine terms. 2x plus x is 3x. 5 plus 3 is 8. 3x plus 8 equals 5x minus 2. Then I want to get the x's on the same side, so I subtract the 3x from each side. That gets me 8 is equal to 5x minus 2. I want to get the 2x by itself, so I add 2 to both sides. 10 equals 2x. To get the x all by itself, I divide by 2, meaning 5 is equal to x. There we go. Now that we know that, let's start plugging it in. Starting with AB, 2x plus 5. 2 times 5 is 10. 10 plus 5 is 15. Next, BC, x plus 3. 5 plus 3 is 8. Finally, AC, 5x minus 2. 5 times 5 is 25, minus 2 is 23. Just to confirm, 15 plus 8 is 23. So now that we've tried that, let's now talk about midpoint bisectors. So, in this case, the midpoint. The midpoint is the point that bisects or divides the segment into two congruent segments. So if you hear the word bisect, it means cut into two equal parts. Next, we have a segment bisector. It's any ray, segment, or line that intersects a segment at its midpoint. It divides the segment into two equal parts at the midpoint. So now let's try out a problem with that. So in this case, our problem is going to be this. 2x plus 4 is going to be AB, BC is 3x minus 9. So in this case, we actually know that 2x plus 4 is equal to 3x minus 9. So at that point, we solve by first getting the x's on one side. 4 equals x minus 9. And then I add 9. 13 equals x. So now that I know that 13 equals x, I go up and I just plug it in. 2 times 13 is 26 plus 4, meaning this is 30. But let's also look at the other side just to make sure. 39 minus 9, that's also 30. So they are equal. And if I wanted to figure out AC, I just say AC equals 2 times 30, which is 60. All right, let's try this one right here. In this case, what we know is the whole length is 8x minus 10. And right here, the AB is 3x plus 6. So what I would do is I would say 3x plus 6 times 2 is equal to 8x minus 10. So in this case, I know that 2 times this is half of 8x minus 10, so I just multiply it by 2. That gets me 6x plus 12 equals 8x minus 10. Then I would subtract, not 2, I would subtract 6x, and that would get me 12 equals 2x minus 10, add 10, 22 equals 2x. At that point, well, x equals 11. So now if we wanted to find BC, or if we wanted to find AB or anything, we would just plug it in. So if I wanted to find BC, well, I know it's the same as AB. So I would just do 3 times 11 is 33 plus 6, which means BC would equal 39. And there we go. That's how we solve some of these segment addition, postulate, and midpoint problems. Thank you all very much. Okay, and that's measurement with line segments. Thank you all for watching. Please like and subscribe, and have a great day. Bye.